You probably think you know me. You think I'm just numbers on a page, abstract equations, maybe a subject you either loved or hated back in school. But that's not my real story. My story doesn't begin in a classroom. It begins in the mud and the dust of a rising empire, with a problem that seemed absolutely impossible to solve.
So imagine this, a young student sitting on the floor of a Babylonian school, a wet clay tablet in his lap. His teacher gives him this riddle. A square field, 30 units on each side. Okay, simple enough. But the diagonal? Well, that's the square root of 1,800, a number that just goes on forever.
And here's the kicker. They had none of the tools we take for granted. No calculators in their pockets, no concept of a decimal point, no x or y to just rearrange in an equation. So how could they possibly find an answer to this, let alone an answer that was shockingly accurate? They could because they had me.
That's right. I am mathematics. And I wasn't born in some ivory tower. I was forged in the real world to solve real problems. I'm not an abstraction. I am a tool. And my story, well, it really gets going with the demands of a king.
Okay, so let's go back about 4,000 years. The city of Babylon just explodes into a superpower. You've got kings like Hammurabi, and suddenly it's the center of this huge, complex empire. And you know what comes with complexity? Chaos. The empire was practically drowning in its own success, and it desperately needed a new way to think, a new way to bring order to everything.
I mean, just look at the daily lifeblood of this empire. Every single one of these activities demanded calculation. How much grain does this village owe in taxes? How much food does this army garrison need? How do we divide the water from the canals fairly so nobody starves? These weren't theoretical questions, right? The survival of the entire state depended on getting the numbers right, and this created this massive demand for a whole new kind of professional, the scribe.
This is where I was really professionalized. The Eddeba, which means tablet house, was basically the world's first professional school. This wasn't for everybody. It was an elite vocational academy. Its whole purpose was to create an army of administrators, the human computers who would run the entire empire. And their training? Let's just say it was intense.
From sunup to sundown, it was just this brutal routine of copying, memorizing, and solving problems. We've even found tablets where students talk about being beaten for making mistakes. They took this so seriously because I was the key to everything: power, prestige, and the functioning of their entire world. And at the heart of their power was a secret weapon, a totally revolutionary way of seeing numbers.
You see, they didn't count in tens like we do. Nope, they counted in 60s, a base 60 or sexagesimal system. Now, at first glance, that sounds super clumsy, right? But for the world they were living in, a world full of division and fractions, it was pure genius.
Here's where you can see the magic. Our number 10, you can only divide it evenly by 4 other numbers. But 60, look at that. It can be divided cleanly by 12 different numbers. This huge flexibility was a game changer for one really important reason: fractions.
Just look at this. In our system, a simple fraction like 1/3 turns into that messy, repeating 0.333 forever. But in base 60, it's just a clean, exact number, 20, as in 20/60ths. 1/5 is just 12. This knack for handling fractions so easily and precisely made all their complex calculations way more manageable. It was the engine of their whole mathematical revolution.
So armed with this powerful new system and years of tough-as-nails training, the scribes were ready. They could finally turn their full attention back to the practical problems of land and trade and building that had created the need for them in the first place.
So let's go back to our student and his so-called impossible problem. Find the square root of 1,800. Now, the scribes knew they couldn't find a perfectly exact answer, but they had developed these really sophisticated algorithms to get incredibly close. The question is, how close?
Well, on one famous clay tablet, which we now call YBC 7289, a scribe calculated the value for the square root of 2. And in our numbers, their calculation comes out to this, an absolutely astonishingly precise figure.
And when we put their calculation right next to the modern value, just look at that. They were accurate to 6 decimal places. This was done nearly 4,000 years ago by hand, scratching marks into wet clay. It's truly incredible.
But they didn't just stop there. Oh no. They tackled problems that we would instantly recognize today as algebra. Take this common riddle from their tablets. You know the area of a field,
and you know the sum of its sides. So what are the actual dimensions? This is a quadratic equation, just disguised as a surveying problem.
And they had a step-by-step procedure, a recipe, to solve it every single time. It's a geometric algorithm we now call completing the square. By following these steps, they'd find the answer. The length is 20 and the width is 15. In effect, they had discovered the quadratic formula 3,000 years before it was formalized in Europe.
But my power wasn't just stuck on the ground in the fields of Mesopotamia. It reached for the heavens. And it was in astronomy that my Babylonian toolkit was pushed to its absolute limit, leading to some of humanity's earliest and greatest scientific achievements. They saw the night sky as a predictable, complex machine, and they used me to decode it. They tracked the planets, they predicted their positions for centuries into the future, and they even discovered the Saros cycle. That's the 18-year pattern of eclipses. This took painstaking observation combined with just staggering computational power. Their work became the foundation for all of Western astronomy. But empires don't last forever. The Babylonian civilization, it eventually declined. New languages, new cultures swept through the land, and the secrets held in all those clay tablets were lost. The cuneiform script became unreadable. It fell silent. For almost 2,000 years, my Babylonian origins were a complete mystery. The last known cuneiform tablet was written around 75 CE. And then just nothing. Silence. Until the 19th century, when scholars finally cracked the code and the incredible achievements of the scribes were revealed to the modern world once more. But here's the really cool part. While the tablets themselves were buried and forgotten, I wasn't. My ideas, base 60 for our clocks and our angles, astronomical methods, algorithmic problem solving, they had been passed on to the Greeks and other cultures. They became so deeply embedded in human thought that we even forgot where they came from. They just became a permanent part of who we are. My story really proves I am not an abstract game. I am a response to human need. The Babylonians needed me to manage grain and land and the calendar. Their needs forged me into what I was. So I'll leave you with this question. What are our impossible problems today? What necessities of data, of artificial intelligence, of understanding the universe are forging the new mathematics of tomorrow?